and thanks everyone for joining us on this webinar. Now, before I jump into talking about how to leverage browser isolation in secure anonymous operations, I thought I'd just do a quick poll to try to get a better sense of where you guys are coming from and make sure that I'm targeting this discussion appropriately for you. Because there's all sorts of different ways and missions that misattributed browsing can apply to, and so we want to make sure that we're going to address specifically where you guys are coming from. I also want to point out that we have some materials available to you as part of this webinar. So if you look inside your application, you'll see in the handout section we have a report from an analyst group called IDC talking about how isolation-based security is developing and that sector of the security space. We also have a white paper on how our Passages product works and our Infusion product. So if you're interested in looking at some of the tools that we have to support non-attributed or anonymous operations online, that'll at least give you a general sense of the kind of capabilities that we can provide. All right, well, great. Thanks very much for filling out the poll. I think I've got a slightly better idea now of where everyone's coming from. So why don't we go ahead and just jump in here? I think the real first question to ask is, why do you want to be anonymous? After all, there's a lot of work involved in being anonymous online. It can be a big hassle. You need to use special tools. You need to pay attention to your operational security, make sure you're not accidentally leaking information. So it's really key to understand exactly what is your mission objective and what are the consequences of not being anonymous, of actually getting identified when you're trying to engage with whoever your target may be online. And that can be anything from just you'll need to get a new persona because you've identified yourself, and so you need to set up a new profile on Facebook or Twitter to engage with your target, to really serious consequences. I was working with a customer once and I said, so what is the driver? Why are you buying this anonymous? In this case, it was a communications capability that we built. And they said, well, we've got these people that we're trying to interact with in this country. And it turned out that one of the people we were working with was actually unreliable and told the bad guys how we were communicating with them, and the rest of the group all ended up minus their heads in a ditch. That's a pretty severe failure mechanism, and so they were coming to us because they needed to make sure that the people they were working with actually survived. And in that case, right, it's worth spending a lot and making sure that you take extreme measures in your operational security to protect your users and your operators when it's actual lives on the line. Now, you may want to use online misattribution when you're doing things like online research. Mergers and acquisition activities, for example, or research and development, where you don't want to sort of expose your areas of interest. Obviously, all kinds of investigations, from fraud to legal to criminal investigations. Open source intelligence gathering can be key. If you want to be able to go and see what are people saying, even if they're not trying to hide it necessarily, if they see that you're expressing an interest, it exposes your interests to them, and they may then start taking countermeasures or hiding. And of course, if you want to get in an infiltrated group, say you want to hang out inside some hacker forum, it's critical that you're not doing that as a major security company or a law enforcement IP address or something like that that's going to expose exactly who you are. Now, we see a lot of people when they're going online taking this very lightly, and they've almost bought into this old myth: on the internet, nobody knows you're a dog. This comes from way back on the New Yorker, and of course, it's really 100% wrong. Right? In fact, on the internet, everyone knows who you are, what breed you are, whether you've gotten your shots, whether you've been spayed. Right? The internet tracks an incredible amount of information. In fact, I would say that the internet is the single most exposed field of operations that you can engage in. Right? There's really nowhere to hide. Absolutely everything you do on the internet is visible to someone. You're always leaving a track no matter what. And sometimes when we talk to people about conducting operations, they say, you know what, I want to be invisible on the internet. I want to be the ghost in the machine. And really, that's not possible. Always you are leaving some kind of a fingerprint, some kind of a track behind. Even if you were completely anonymous, the fact that you're completely anonymous itself is an interesting tell and provides a lot of information to the websites you're visiting. So you really need to choose exactly what you want to look like, understand what you're trying to accomplish, and so forth. So let me do another quick poll here. And I want to understand from you guys, what do you conceive of as the biggest risks of using a browser online? And what are your concerns? So I can make sure that I hit those points while we're doing this conversation. And so we're looking at, are you worried about drive-by downloads? And by that, I mean a website that automatically launches malware and downloads it to your computer as soon as you view the website. So this would be things like malvertising. Are you worried about sophisticated opponents using 0 days, using the really difficult or impossible to detect kinds of malware? Are you worried about being tracked or identified while you're engaging? Are you worried about blowing your operation when you're trying to gather information? Or you may be worried about targeted attacks, spear phishing, and what we might call snipers at the watering hole, where we're seeing a lot of web-based attacks that are not attacking everyone who visits a website, but are only attacking certain individuals who go to that website, and that makes the attack much more difficult to detect. Great. Looks like, in fact, the majority of you are worried about the drive-by downloads and also concerned about tracking. Great. So I'll make sure I hit all of that really thoroughly as we're going through here. No matter what you're trying to do, whenever you're engaging online, it's really critical to be thinking about your threat model. What are you going up against? And I tend to get into sort of a moment of Zen at this point, thinking about Sun Tzu, right? You need to know your enemy and understand who they are and what they're trying to accomplish and what their capabilities are. And I think there's 3 sort of main aspects to that that I worry about. And the first is their resources. What can your opponent do? Do they have really smart people? Do they have money? Do they have specific knowledge? Do they have surveillance abilities? Do they have access to legal search and seizure, subpoenas? Can they compel cooperation from the ISP? So depending on who you're concerned about watching you and what you're concerned about them seeing, you need to understand in a great deal of detail what they can bring to bear to try to get that information, right? If you're trying to go after some low-level criminal, they're not very well resourced. If you're trying to go up against some nation state in their home country, they're going to have a huge home field advantage and tremendous resources at play, both human, knowledge, technology, money, right? All of that will be available to them. And that really dictates what you need to put in place, right? If you're trying to go up against Tony Stark, you'd better be bringing your A game. You also need to think about what kind of technology do these people have? What monitoring capabilities do they have? How well can they automate their tools? What kind of maybe active countermeasures do they have in place? Do they have tools that are looking for anomalies? Can they spot inconsistencies? Can they troll all of your activity and look for, say, reused accounts, shared usernames, shared passwords? Because a lot of people trying to be anonymous have gotten tripped up by exactly that kind of thing. In the Silk Road, the operator of that underground sort of crime bazaar went by the name Dread Pirate Roberts, and he ended up getting caught because very early in his career doing this, he had accidentally reused some accounts, he'd shared usernames, and some of his writing patterns and styles had been recognizable. And just because of those little clues that he'd left behind, he was able to be caught because the FBI that was going after him put a huge amount of effort into looking for those needles in the haystacks. And so that level of effort is critical. It also comes down to paranoia, right? when you're going after someone, how hard are they looking for you? Right? If the person you're engaging with has no suspicion that anyone's trying to be anonymous around them, then you don't need to probably work that hard, even if they're really smart. If you're going to Google and doing a search, even though Google has tons of money, tons of technology, and tons of smart people, they really don't care who you are in general when you're just doing a web search. They're not going to try that hard to uncover and undo whatever tradecraft you've put in place. However, if you've got a fairly low-tech person, low-resourced, but really paranoid, they can spend a lot of time digging, right? They may be watching all of their web logs really closely. In fact, a friend of mine got caught by this. He was looking for an old high school acquaintance of his, went on to Google and did this search string, put together everything he knew about this guy, where he lived, what school he went to, his parents' name, friends, pets, whatever, all into one giant Google query and submitted it. And sure enough, this guy's homepage came up, his private website. And so he went, clicked through the link, looked at the website, and said, great, now I know how to contact him. I'll call him on this weekend. Well, this was a paranoid guy, and he actually watched all of his logs and watched the refer information, which, among other things, tells you what search string led you to the website. And when this guy saw basically his entire life story showing up inside that query string, he had a cow. He was incredibly worried that someone was after him and who knew all this information and what was going on and was he being stalked, and he got himself so wound up and was really not at all happy to hear from my friend when he finally called, because it sort of ruined the next 3 days of his life. But this guy had no particular technical sophistication, but he was paranoid. He was watching really closely. And so understanding what are their resources, what are their technological capabilities, and how paranoid are they can really help shape what things you need to be doing to make sure that when you're engaging, you can be effectively misattributed and anonymous. So how do they identify you? Let's take a look at what they're doing to look at who you are. The most obvious thing they use is your IP address. Right? Every connection always leaves an Internet Protocol address behind. It's like the return address on an envelope you send from your house, and you can't just make up an address or the response letter won't get back to you, right? This has to be a real IP address that exists somewhere out on the internet. And that's what allows this two-way communication. And there's a lot of information you can get from that IP address. There's a lot of public databases that show who's the IP address registered to. You can see what ISP owns it. You can see a lot of other information. But also the bad guys are building databases specifically of this kind of information. So here's a real website, Who's a Rat, at who'sarat.com. And this has a huge database of known agents, lawyers, corporate investigators, but mostly law enforcement and intelligence services, and they're building this database of information about them so that if you're a criminal, you can spot when those people come in and automatically take countermeasures or do something else. But it makes it very easy to keep track of those people. So the bad guys are getting very active and pretty sophisticated in a very turnkey way. So even if the individual isn't sophisticated, if they know about this website, they can leverage what this website is doing to track the people who are trying to go after them. Now, once you've got an IP address, you can also learn a lot more about the network it's connected to using a number of tools, the best known of which is called traceroute, that allows me to analyze, allows anyone to analyze all of the hops an internet packet goes through between the sender and the receiver. And so when you're going out to the internet, they can look back and see what path are your packets taking. And so they see not only your network, but they see what your network environment looks like. They can see what your ISP is. They can see who that company's ISP is. And so even if you've managed to make sure that your IP address doesn't resolve to your organization, are you coming out of a block of IP addresses that associate with your organization? Or does it show maybe your upstream provider, and that's a big data center, or that's an ISP that maybe your opponent can social engineer? Right? If they're aggressive, they can call into that ISP and get information about who you are if the people at the ISP are witting of your identity in acquiring and purchasing that IP space that you're using. And of course, even if you're using anonymity tools, if you're using public ones that are well known, those IP addresses are recognized and known as part of those organizations. So like I said, you're always leaving a fingerprint. What you need to do is make sure you understand what parts of the fingerprint do you care about, what parts of it are likely to be visible to the particular opponent you're worried about, and what do you want to look like. Always being conscious about forming that fingerprint to your needs and requirements. Now, we're also seeing a lot of websites doing location tracking, where they're actually going to try to know where you physically are in the world. And there's a lot of ways they're doing this. Some of them are a little bit surprising. So, for example, when I got my first iPad, and I got one of the first generation ones, and it was Wi-Fi only, and it didn't have a GPS in it back then, and I opened it up, and I said, oh, this is really cool, and I opened the map application, and it immediately dropped a crosshairs right on my house. And I said, what? What just happened here, right? How did this iPad know where I live when I'm not giving it any tools, right? It doesn't get cell tower information. It's not getting GPS. It's not tracking satellites. How in the world did it know where I was? Well, I did some research and found out. What they're doing is they've actually mapped the location of every Wi-Fi hotspot basically in the world. And your device, even if it's not logged into Wi-Fi, can look at all the Wi-Fi base stations around it, their relative strengths, and use that to calculate a location, even indoors, to within maybe 10 feet or less. Very accurate, very fast, and in fact, we're all complicit, because if you've got an Android or an Apple phone, any smartphone with GPS, it's always sending back up, where am I? What's my GPS location? What cell towers can I see? And what Wi-Fi can I see? And it sends that triplet of information up. And then with the database, they can reverse that, right? If you see this Wi-Fi, therefore you are in this location. And so that's become a really common and effective way of doing things. So if you are on Wi-Fi and you're using a normal computer, it's very possible for your opponents to identify you. Most browsers will at least give you a pop-up that's a heads up that they're asking for your location information. But if you've ever said that's always okay, they'll always be able to do that. So make sure you check your preferences on that. But there's a lot of other ways. For example, your IP address is probably a pretty good proxy for where you are. It's certainly registered somewhere, so I can see where it's registered. If your device has GPS, of course, then it can be handing this over. There's the cell towers, Wi-Fi I talked about. Behavior is a really interesting one. And we discovered this with Google, that we had points of presence in certain locations. And so let's take a Dilbert example. Let's imagine I had a point of presence in Elbonia, and your traffic is actually coming out of Elbonia, but you're really sitting in Chicago. We had a bunch of users who were using this point. We get this phone call that says, hey, Google knows that we're in Chicago, but we're supposed to look like we're in Elbonia. And we had a cow, because we're like, oh my God, there's something wrong, something's broken. And we did a lot of tests, and there was nothing broken, and all of our technology was working correctly. So then the question became, well, what is going on? Right? Why is Google thinking this? And we did a bunch of research and discovered that the way Google was recognizing where your IP address was by looking at your search patterns. What kind of searches did you do for restaurants, for schools, for barbershops? What sort of mapping do you do, right? If you're asking for directions to someplace, where are you coming from? Where are you going to? And if you look at that over a block of IP addresses, and they were looking at it, what's called a Class C, a block of 255 addresses, if you look at the average location of those queries, that's going to be a really accurate location for where those IP addresses were. And because our customers were using us for personal use as well as for their non-attributed online operations, Google very quickly discovered that, yep, they're in Chicago, or they're in Fargo, or wherever they actually were, rather than where the traffic was actually coming from. And of course, Google shows this to you because when you do a search, it tries to default to where it thinks you are. But in fact, lots of websites have access to this kinds of information based on your behavior. A sports website would know what kind of sports teams you're interested in. And then, of course, a lot of websites are now basing it as well on purchasing. So when you buy something, they can look at the billing address and they can look at the shipping address, and that's being provided to companies that build these databases. So every time you interact with a website, you can be leaving behind cookie crumbs that are going to help identify where you are. And if it's important to control that, it's important to be thinking about how you manage your apparent location online. And then, of course, there's cookies. Cookies are always a problem. Almost every website sets them on your computer. They're fairly easy to delete, but there's something called super cookies, which are not so easy to delete. These are sort of using tricky techniques to get the browser to save data. And it can be things like flash stored objects, it can use active content, they can look at unique URLs that they'll load an image from and then look to see in your history whether that's been visited. Lots of ways of setting trackers on your computer. Some of those are very difficult to remove without using special tools. And then they can actually just fingerprint your entire browser and computer. And this is something not many people are aware of, but the set of characteristics that your browser reports to every website you visit tells a lot about your computer. It contains information, the obvious stuff, are you running Mac, Windows, Android, iOS, what version of the operating system, which browser, what version of the browser, but it also things like every plugin you've got, every font you have installed, every language that your computer supports. And in fact, the way in which it reports this reflects the order in which these things were installed. So when I look at all the data I can collect, it effectively uniquely identifies your computer for any but the very largest websites, uniquely in the entire world. But you will be the only person who's ever visited the website with that particular recognizable fingerprint. And so when you come back, they can immediately recognize that it's you, even if you've deleted all of your personal information. And in fact, this is already being actively used by advertising websites. So when you see a banner ad and you've deleted your cookies, they'll often try to use browser fingerprinting to recognize who you were and what ID they had on you before, so they can re-cookie you and reacquire your identity. And the advertisers are using it. Certainly, bad guys are using this as well. A great example of how this works is at a website hosted by the EFF, the Electronic Frontier Foundation, called Panopticlick. And it's worth just making a quick note of that URL. Check it out. It's kind of amazing how much information that these websites can actually see about you, and it'll give you some accurate information about exactly how much you look like everyone else who's visited that website. Now, leakage is also a problem. When you're trying to hide who you are, there's a lot of ways in which that data can kind of sneak out around the corners. So even, for example, if you're hiding the origin of your web activity, your computer may be doing domain name lookups directly. And if they're watching their DNS servers, they'd be able to see where you were coming from. Or if you're using certain applications, or if you're on a mobile device using apps, even if you're protecting your browser, they may be phoning home and reporting on you. If you're using a proxy, you need to make sure lots of public proxies that are out there will actually embed your real IP address in a header as they pass it along. So it's important to look closely at what information is making it through to your target to understand what other sources of information you might be providing there. They're going to undo all the work you're doing to try to hide who you are. And then, of course, if they can get malware on your system, they've really got you, because it can sit and watch what your real IP address is, what your real network information is, what the name of your domain controller is on your network, and can scan out from there. It can probe, it can see the real IP addresses. So if they can actually get you infected, you're really in a world of hurt. And finally, of course, the human turns out to be the biggest problem. And the human can make all of these mistakes that will expose you in all sorts of ways. I had a good friend in law enforcement who told me this story. They had a computer that they used for primarily undercover connections, and they were doing this deal with a narcotics investigation, and they were chatting with this guy, and the investigator had to leave. Well, one of the other guys in the office was having computer problems, and so he said, I know what I'll do. I'll just go to this computer and reconfigure it to point at my email account, and then I'll send off this email that I needed to send. So he did that. The first guy comes back, sits down, doesn't realize this has happened, and immediately sends an email from his colleague's law enforcement email address, pretending to be a drug dealer to this, narcotics bigwig. Needless to say, that operation didn't go well. But making sure that you never make those kind of human mistakes, that you never use the wrong account, send from the wrong place, expose the wrong kind of information, even once, is really difficult. And having the right framework around you, the right processes, the right tools, the right environments can make a huge difference in your ability to actually maintain that extremely high level of OPSEC that's so important. So what can they do with this, right? Once they've identified you, what are the threats that you need to worry about coming back at you? And we think that there's basically 4 main categories of threat. There's exposure, blocking, cloaking, and attack. So let's take a look at those individually. Exposure. In this case, we're concerned that when you are identified, they've now seen who you are. And so for example, if you're doing M&A research, mergers and acquisitions, the target that you're connecting to now knows that large investment bank, major competitor, gigantic Fortune 50 company is going in and looking at their financials, their last quarter reports, whatever kind of information you're looking for exposes a lot about what your interests are. And so just being seen can make things go sideways, right? If you're investigating some group of child pornographers and they see law enforcement coming in, they're going to shut down that operation in a heartbeat and set up shop somewhere else. And now you're starting from scratch with your investigations again, right? You've given away a huge amount of information, and they're then able to take countermeasures and change their behavior, and they're now going to be more paranoid too, right? You've suddenly ratcheted up that paranoia level that makes all of your problems more difficult. Of course, they can block you. Right? Once they've recognized who you are and where you're coming from, they can just set up their websites, their chat clients, any of their tools to simply not allow you to come in, right? Just completely block all of your access right from the start. And this is pretty straightforward, but of course when they do that, you know that, right? You can see you've been blocked. The site's throwing up a 404 error of some sort. So the next layer of sophistication is what we call cloaking. And it really has to do with the problem that when we talk about the internet, we're a little sloppy with how we use that phrase because there really isn't the internet. It's not some object that's sitting out there that we can all look at and we can all agree on what it is. In fact, anyone who visits a website these days probably sees a different website, right? They're almost all dynamically generated. They're all being built by scripts, by JavaScript, by back-end CGIs. They're pulling from databases. They're deciding, where are you? What stories might you want to see? Which ads are most appropriate to show you? Where do you live? Let's show you local news. Let's show you local weather. Let's show you the appropriate content. So everyone looking at the internet effectively is seeing a different internet. And that allows them to do what we call cloaking, which is provide you different information based on who you are. So let's imagine you receive an anonymous tip about a terrorist website, and it's called reallyevildude.com. And yeah, we did register that name. And so you go to reallyevildude.com, and while it's loading, and in fact, before you even see anything come up, it's going to look at who you are and where you're coming from. It's going to analyze what's your IP address, what's your browser fingerprint, can I tell what organization you're with, where you are. You're with, looks like a government organization, you're in the DC area, I'm going to show you the innocent version of the website. And so maybe I'm going to say, okay, you can see the martyr videos because I want you to think that this is the rest of the website. But there's a discussion forum. I'm just going to make it so that that link isn't even visible to you. We've shown it gray, but in fact, it just wouldn't appear on the website, wouldn't appear in the website source code. So when you're looking at this site, you think you're seeing the site, but actually you're seeing a modified version. And they can even get really evil. For example, they might say, we're going to have this meeting Tuesday. If you want to join up, come in, knock on the door and say Joe sent you. But the real password was Frank. Only people who looked like law enforcement saw Joe. And when your poor agent in the field knocks on the door and says, Joe sent me, he's about to have a really bad day, right? Because he just announced to everyone there that he's actually an undercover person. And that's really bad. So the implications of being discovered can go from very mild, you've sort of exposed the fact that you're interested to something, to, as I talked about before, really life and death issues. And you can open yourself up to counterattack, right? If they recognize you as law enforcement, that may put a target on your chest, and the people you're going after are going to say, this is a law enforcement guy. Let me send him malware. Let's launch that exploit against his browser. Let's see if I can hack back against these guys. Because those nice rules of engagement often don't apply to terrorists and hackers and criminals. They want to shut you down. They want to get on your system. They want to know what you know about them. And so if you're recognized, suddenly you're in the crosshairs for potentially aggressive countermeasures. In fact, if you're investigating, say, from a corporate SOC, and you're trying to go into a hacker forum, and they recognize that you're from, Acme Megacorp, they may then launch a DDoS attack against your company just to sort of dissuade you from trying to poke your nose in their business. Lots of kinds of attacks that they can launch based on the fact that they see you snooping around in their business. So hiding that can be really important. So what can you do about that? We think that the key here is using isolation and virtualization to protect yourself, both your identity and your security, when you're doing these kinds of engagements. So let's look at the isolation for anonymity. Normally, you're using your desktop and you've got all of your information there, right? Your real identity is on your desktop. You've got all your personal files, your location, your organization is discoverable. So if you're trying to do investigation from your actual desktop, that's all vulnerable to discovery. And if anything slips up or slips through or leaks, then suddenly the bad guy's getting that information and potentially being able to compromise your real infrastructure, the stuff that you're trying to protect. So if you can isolate that away, you can then create an operational environment where you don't have any sensitive files. You have a false location. It's tied to no organization or to a fake organization. And if that gets compromised, they only see that, but they don't get access to your real desktop with your real information. And so using a virtual machine, you can separate out these two different spaces and have the virtual environment for your operational activities and your real desktop for your real activities, your real files, the notes you're taking, right, all the information on the case and the people you're investigating, and make sure that those streams don't cross, right? It's like the Ghostbusters, never cross the streams. Now, a general purpose virtual machine isn't going to accomplish this because it's designed to share things with the desktop. It's designed to be super integrated. So when you're building out a virtualized operational environment, it's critical to make sure that it doesn't have access to or information about that local network. It really needs to be carefully isolated, not just inside the virtual machine, but with IP spaces and domain controllers and file system sharing and everything else. That all needs to be restricted to make sure you've got that robust isolation between the ops environment and the desktop. But you also want to be isolating for protection, right? You're going after often bad guys, and they may be trying to hack back against you. You want to make sure that that infection can't make it back through. And so one of the nice things you've got with virtualization is containment. So we all know that browsers are continually having vulnerabilities discovered. Right? There's hundreds of major security patches on all of the browsers every year, and it's because they're gigantic. Right? These are enormous pieces of code. They're many millions of lines. Most browsers run something like 4 different Turing-complete programming languages, so they can execute any code that someone wants to send in. And knowing what's going to be good, what's going to be bad, it's effectively an impossible problem. But with a virtual machine, even if the browser is compromised, it's always captured inside that virtual box. And because there's no important data in there, you can actually just destroy that at the end of your session. Who cares? Blow it away and then rebuild it. And that guarantees any malware is gone. And the nice thing is it even gets rid of malware that you were not able to discover, right? Even if you've got scanners running and they attack you with a 0-day, it still gets destroyed when you destroy the virtual machine and recreate it from scratch. So containment provides enormous amounts of protection. But it also allows automated repair. So when you get infected, if you shut down the VM and recreate it, you've now basically is equivalent to re-imaging your entire computer, but without the inconvenience, right? You didn't have to re-image your whole computer. You just killed the VM and restarted it. So it automates that whole process and allows you to go through and get back to a known clean state very, very quickly. And it allows you to do it whether or not you detect anything. And that's really one of the key things. Currently, malware detection technology is really lagging behind the evasion technologies that the hackers are using. All of the malware is getting extremely polymorphic. In fact, I saw a study recently that said that almost like over 90% well over 90% as I recall, of the malware samples that this company was picking up were unique to that endpoint. In other words, that signature had never been seen before. And it's not that it was a 0-day, it was not some brand new kind of malware, but they were modifying the content, modifying the signatures, automatically permuting variable names and all the other kind of stuff inside that virus every single time it was deployed. And so it can be extremely difficult to know that you've got it, especially for the browser, because normally with browsers you have to decide in a millisecond whether or not a file is good or not. You can't do deep inspection. If it's in a virtual machine, you can then just automatically blow it away, even if you haven't detected it, right? And so just making that a regular habit, at the end of every hour, at the end of every day, you wipe the VM, put it back, that guarantees you're clean. But when you're building these systems, when you're looking at how to deploy non-attribution systems for doing anonymous research, it's really critical to make sure it's easy to use. Now, if someone needs to do a bunch of command line stuff, they've got to spin up other environments or have multiple computers, they're just going to drive around the security mechanism, right? You put a gate on a road, but you don't put fences on either side, people are going to go around it because you've made life inconvenient for them. So it's really critical that whatever workflow you develop, especially if you're building this workflow for other people and it's not something you've that's your own baby that you built for yourself, making sure that it effectively doesn't change their user experience at all is incredibly important. And then enabling oversight. In most organizations where they're allowing any kind of misattributed or anonymous investigations, it's incredibly important to have organizational and management visibility into what's being done, so that if something is done improperly, that can be recorded, that can be captured, you can prove that everyone is behaving as they should, and you can keep track of the kinds of activities people are engaging in. So when you're building these tools, it's often easy to make it so that you can't even track yourself or your own people. In general, it's very important to design these things to still enable oversight and tracking and management and logging and all of those other activities that your organization expects you to have. So we have two main solutions that we've built for supporting these kind of activities. And the first one is called Passages. And Passages is a secure, isolated virtual browser. And so in this case, we're just looking at running a browser. In fact, this is a picture of what it looks like. It looks like and is a Firefox browser, and it runs on your desktop, runs in both Mac or Windows. And it provides safety against unknown attacks because it's running a full virtual machine. It automatically resets the virtual machine at the end of every session. It provides misattribution transparently. So when you're using it, you're always misattributed, and you get to pick where you want to come out from. And it's generally user resistant, or at least user tolerant. That is, if you're using Passages and you click on some link on your desktop, if we're your default browser, you're never going to end up then getting infected with malware because you visited it, right? Worst case, it's going to be trapped inside that virtual machine. And even more so, if you're going out to bad websites and they try to attack that browser, it's always going to be trapped. To give you a sense of what that looks like, the virtual machine is running on your desktop, so you get like normal browser performance. We're not trying to remote desktop into some distant location. It's a conventional browser running Firefox inside the virtual machine. It has a ton of plugins to support all kinds of collections activity and screenshotting and password management and all of that good stuff that you're used to having in your browser. But the virtual machine is actually running Linux, and we chose Linux for a couple of reasons. Having a Linux operating system makes it inherently immune to the vast majority of malware that you're actually going to encounter on the internet, right? When you go out there, almost always the malware you're going to run into is built for Windows. If it isn't Windows, it's probably Mac. If it's not Mac, maybe it's Android. Almost no one except security professionals runs Linux as their endpoint desktop. And therefore, the bad guys effectively haven't written any malware for it. It's not that the operating system is inherently bulletproof, although we have hardened it very substantially. We're running a custom kernel that we've built, and we've stripped out all of the unnecessary tools and capabilities from the browser, except from the operating system, except just what's required to run the browser. But already, most of the attacks are going to bounce off you. The virtual machine shares no interface, no drivers, nothing with the rest of the operating system, and then all of your traffic in and out goes over this VPN tunnel out to our cloud. And so that's how you're going to get your misattribution. You're going to come out of some IP space that we pick, that we control, and in fact, you have a picker to choose where you want to come from. So you can pick the city or the country that you want your data to emerge from, and you will look like you're coming from that location.
We also store the user's activity information in the cloud. So a record of all the pages they go to, all the sites, all the web forms, whether for unencrypted pages or even SSL pages, because we capture it all directly from the browser, is stored inside our cloud and available to your administrators. And they can look at that either through our Insight dashboard, or that information could be exported to whatever SIEM system that they wanted to use, so that it gets tied in with the rest of your security information and logging data. So at the end of the day, you have this bulletproof, secure browsing environment, which is also providing robust non-attribution, because every time you close out that browser, it destroys all the tracking information, the cookies and the super cookies.
Our other main platform we call Infusion. This is maybe the next step up. It's Passage's big brother. And Infusion is designed to support the entire virtual desktop. So if you need to have multiple applications and tools and capabilities, then Infusion is going to be your better choice. So we support the browser, but we're also going to support email. We're going to support, specialty chat clients, any tool you need to use to interact with the people that you're engaging with online. You can install and run within your Infusion environment. And you can manage multiple identities within that, so it's easy to engage with multiple different parties online in a secure way. In this case, this is all being virtualized in our cloud, so we can provide total management around that. So typically our users for Infusion are sitting inside an operational data center at their organization, connecting into our cloud. That gives a nice high-speed connection, really good user experience. But this allows you to do a broader variety of kinds of activities than just web browsing. And so it's the complete desktop environment, any app you need, web, email, chat, whatever you need to install. Plus it has a bigger variety of collections capabilities. So we can, for example, snapshot all the websites that you're looking at and have an online notebook that allows you to capture information about the people you're interacting with and then save that off into the cloud so you can analyze that later. Provides a lot of help for custody of evidence, for example, so that when you're online, you can demonstrate when this was captured, how it was captured, where it went, and follow it through the database environment. And so in this case, you've got your desktop with just a viewer on it. So now you're not even running the browser or anything else locally, right? It makes you totally immune to any compromise. The entire Infusion operational desktop is running out in our cloud. That's where we're doing all the storage. That's where we're persisting the persona information, all the stored captured data from the websites you're visiting. And from there, you can, again, connect out to our network of geopools to come out from wherever you need to be. So whatever location you require, we've got a whole set of them that are standard that we provide that are shared points of presence. But particularly for Infusion, for higher threat kinds of engagements, we can set up customized points of presence on a bespoke basis to any required level of tradecraft. So we really are doing tradecraft as a service as part of this investigations platform. So with that, I want to thank you very much for sticking with us for the entire presentation. I hope this has been helpful to you. If there's any questions, please pop those into the questions section, and don't forget to grab the IDC report on the Passages or Infusion white papers that are available in the handout section in the presentation software. And of course, please visit us on the website. Lots of more information about how Passages and Infusion works. We've got a blog where we talk about all kinds of security issues and investigations, best practices. We have records of other talks that we've given, and of course the recording of this presentation will get uploaded to YouTube soon, and you'll be able to capture that there as well. So thank you very much. I really appreciate your listening to us, and have a great day. Thanks.